last time, while discussing about the topics of the center of mass, I had told this to you that if I have a discrete system of particles, then there is one separate formula to calculate the center of mass, and if it is a continuous mass distribution, then there is a separate formula. For discrete one, we can simply add them up, where we use the summation over I. And for a continuous mass distribution, we said that we will have to integrate the system. So here I have taken an example where I will have to use this integration. That is the reason why I have taken this example. It says that there is a thin rod of length L which lies between x equal to 0 and x equal to L. So these are the starting and the end points of the rod. The linear density of the rod varies with x. That means at different positions of the rod's length, the density is different. And what is the density? It varies according to this relation k times x by L to the power n, where k is any constant, L is the total length of the rod, x is that particular position where we are calculating the density, and n is a number that can be either 0 or any other positive integer. Now, if in such a case we plot the center of mass versus this number n, how will it look like? So this was a question from joint, and there were these three options, option A, B, C, that now if I plot the center of mass versus n, how will it look like? So this is the n axis, this is the center of mass axis, this is the midpoint L by 2 of the rod's length, this is the total length L, as you can see. So first of all, in order to find out how the center of mass will look versus n, we will have to find out where center of mass lies. So for that, we will use the formula that center of mass is equal to, as we said, for a system of continuous masses, it is equal to integration of x dm divided by integration of dm. Now what is dm? Dm is a small amount of mass. So if this is my rod, then dm is a small amount of mass of this strip, and that is equal to the density at this particular position of x, as density is a function of x, times the length dx of this strip. That is how we can find out the mass. So substituting it here, we get integration of x rho dx divided by integration of rho dx. Now what is rho? Rho is this relation k times x by L to the power n. So this is x times k times x by L to the power n dx integration, and in the denominator we have x by L to the power n dx integration times k. Now obviously this k is a constant, so it will get cancelled, and L is also a constant, so we have L to the power n here, L to the power n here, so L will get cancelled. What basically remains is x to the power n plus 1 dx integration of this thing divided by x to the power n dx integration of this thing. If you use the integration formula, this becomes x to the power n plus 1 n plus 2 divided by n plus 2, and in the lower part we have x to the power n plus 1 divided by n plus 2. And since this is a definite integral, it has limits from 0 to L. So it has limits from 0 to L. So we will put the value of the limits. So first of all, this expression becomes x to the power n plus 2 by x to the power n plus 1 times n plus 1 by n plus 2 from 0 to L. So subtracting this basically becomes x times n plus 1 divided by n plus 2 from 0 to L. If you put L in place of x, that becomes L times n plus 1 divided by n plus 2. And if you put 0, well, it is basically 0 in that case. So now what we will do is we will do a just simple simplification, divide each term up and below by n. So this becomes L times 1 plus 1 by n divided by 1 plus 2 by n. So this is the expression for the center of mass which we have obtained. Now let's see what has been asked to be found out. Okay, so we have to find out that what is the variation of this curve here, which will be the nature of the curve. So when n is closer to 0, when n is equal to 0, what happens? If I put 0 in these places, I get basically L. That means at n equal to 0, the value should be equal to, this becomes L divided by 1 plus 1, and here I have simply 1 plus 2 by L, so that becomes L by 2 in this case. Okay, just okay, so you might be facing a difficulty here in understanding how I got L by 2, so let me just write this in a simpler manner. Here this n plus 2, I can write it as n plus 1 plus 1. Okay, now if I divide each by n plus 1, this becomes L, this becomes 1, and this becomes 1 plus 1 by n plus 1. I think that will make things simpler for you. So when n is equal to 0, simply I put 0 here, so this becomes 1, 1 plus 1, 2, so the center of mass becomes L by 2. And what happens when n is equal to infinity? When n tends to infinity, as we can see on this side. So 1 divided by infinity, anything means it is tending towards 0. In that case, it will be L. So that means basically from L by 2, it will increase to L as n tends to infinity. So that is the first curve, option A. So here, though the curve is not so important for your board exams, what is important is to know how to solve this kind of numericals where the density of the mass is a function of positions, and you need to use the expression for continuous mass variation. Now you know this, I had told this in last day's class, in the last video, that the center of mass equation for a system of discrete masses was mi ri summation over I equal to 1 to n divided by total mass. Now what happens if I am trying to find out the velocity of center of mass? I will simply do the time derivative of the position vector. So time derivative of position vector gives me the velocity of center of mass. So that will be 1 by m times time derivative of each of this term